Let's start with the first lab, the lab heartbeat. To complete this lab, you have to open the VHDL code where you find insert your code here of the following files. On the folder to do, open the heartbeat file.vhd and DS0 heartbeat.vhd. This is the top level, and that is a component to instantiate in the top level. You have to implement in the component an entity that toggle a single bit output with a programmable toggle and with the toggle rate that shall be clock frequency divided by a programmable heartbeat divider plus 1. Then simulate your code and lay out your code on Altera Cyclone 3. Let's see what should be the instantiation of your component. You have to select between two different toggle rates selected by the dip switch and connect the toggling output on the first for LED and the second for LED. Remember that board clock is 50 MHz. In this case, in the first for LED, we have to connect the heartbeat, straight heartbeat, and the second for the 1, 2, 3, 4 LED, we have to connect not output. The mux shall be selected with dip switch 9. Okay, let's see how to implement our counter. We have the entity with clock reset, input module, and output bit. We need an internal 32-bit register, that is our counter, and internal toggling bit. Then we have to implement our toggling bit on a process where the counter is reset on reset low. Then we have to count plus 1 until counter reach the module, the programmed module. When the counter reach the module, counter is reset and the bit toggle. Next, we have to assign the internal toggling bit to the output. Let's see how to implement our FPGA. DL0 heartbeat is the top level of the board, of this board. So let's see briefly what are all the signals. We have the input clock, the button, the 3 push button, 1, 2, 3, then the input switch, 10 switch, 0 to 9, the 7 segment display, 1, 2, 3, 4, 0, 1, 2, 3, 10 LED, 0 to 9, the UART, the SDRAM interface, the SDRAM is this one, the flash interface, and this is the flash. The LCD not mounted in this board, the SD card interface, this one, the PS2 interface, this one, the VGA interface, and the GPIO interface, 1 and 2. In this design, all unused pins are set to a value. For the RAM, we set the control active low to high, so the RAM is unselected. And we set to tri-states the data bus. Same for the flash. Don't care for the LCD because it is not mounted. The same thing for SD flash, SD card. Set to tri-states the PS2 port, 0 the VGA, and set to tri-states the GPIO. So let's see how to implement our design. This is the component defined here. So component, earth bit, and so on. Just copy and paste here. Then clock reset, defined as wire, because these are wire connection. The earth bit divider, and we connect the reset on the button 0. So when we push this button, the design is reset. Input 50 MHz clock to clock. The first for LED on the straight earth bit, and the second for LED on the inverted earth bit. Then the 7 segment, the first 2 on, the second 2 off, and the dot point of the LED to the earth bit and not earth bit. The mux, this one, connected to switch 9, is this. So when the switch is off or 0, we select 1 second toggling. When the switch, this one, is 1, we select half second toggling. Earth bit is this one, and this is connected here. Okay, let's simulate the earth bit design. So start model sim and select the folder, the working folder. Course, earth bit. I'll select the solution folder. You have to work on the to-do folder. So select solution and create the simulation library work. Writing VLib work if it doesn't exist. In the simulation folder there is a script on RTL test bench sim, and we can find radix unsigned that let's zoom here. We have the module that is set to 10. In fact, we count from 0 to 10 and then start counting again. We can add a cursor and can check that. Clock period is 10 nanoseconds. So you can see that from edge to edge, 110 nanoseconds, 11 clock cycle high, 11 clock cycle low. So let's learn how to create a simulation script. The simulation script is this one. compile, simulate, add all the wave in the design and force the signal. Then run and force the reset below. So this is force signal and compile, simulate and add wave. Let's understand how to create a script. So exit from the simulation with quit -sim. Okay, clear transcript, right click, clear, and starting from scratch. Delete work. Okay, so delete work. Then compile, press compile button or go to compile menu and compile. Select the file heartbeat and compile. Then you can go to the library work and we'll find heartbeat, right click and simulate. Now we have to add all the wave. So write on the transcript, add wave star and here there is all the wave on the design. And now let's force the signal. Select the signal, right click. We have to force as clock. So select clock and set period of 10 nanosecond. Starting from rising edge, okay. Okay. Reset. Force has 0. Freeze means that the signal is freeze to 0. Heartbeat. We want to force to, for example, 5. Set the base, so 10 hash 5 hash. Okay. This means that I'm forcing with base 10 and we set 5 as number. Then heartbeat, okay. So run, for example, 200 nanosecond, okay. And now we can see the clock period 10 nanosecond and heartbeat divider to 5. Now release the reset, up arrow to recall the last command and set reset to 1. Then run for 1 microsecond. Radix. Let's see. And now we can see that the divider is 5 and each 6 clock cycle the heartbeat toggle. If you want to create a script, it's very simple. Go on the transcript, select all the command and copy the transcript. Then create a new file, and paste the transcript. We can delete all the comment. Here there is the absolute path, but you can change the path with relative path this way, because we set as folder this one, so RTL is a subfolder of the root folder, and we can set -t nanosecond. That means simulate in nanosecond. Save, for example, test. Okay, and go on Model Sim, Tools, TCL, Macro, RTL, Test Bench. Okay, and voila, it's on full. Right click to open this menu. And this is how to create a script with Model Sim. Now we can implement the FPGA. So let's go on Solution and create new folder, new layout folder. Layout. Then start Quartus and on File, click on File and New Project Wizard. Next, select folder. You have to work on To Do, of course. Solution, Layout, open, and select File. File that give the name to the project, the top level. Okay, next, add the files. Open. Next, select Cyclone 3, and the FPGA you have to select is this one. Next, finish. Now start compiling. And do you think we finished? Of course no, because no pins are set. In fact, if you control the pinout file, no assigned pin. We have no assigned pin. So we must assign the pin. How to assign a pin? Assignment, pin planner, and set the location to the pins. This is a way to set the location to pin, where you have to set all the location by hand. Another thing is close this file, close. After create project, exit from Quartus and go to to layout directory. Open the QSF file, and here there is the project file. At the end of the file, copy the pinout provided in DA0 pinout TCL. Select all, copy, and paste at the end of file. Save, and open Quartus, clicking on the project file. Start compile again, and you can see that all the pins are set. And if you open the pin assignment, you can see that all the pins are set. Last step is to run the design on the D0 board. Okay, to run the design on the D0 board, let's turn on the board, start programmer, and start programming. The board is programmed, so we can see the blinking LED at 1 second. If we switch 9, blinking LED going faster. The button 0 is connected to reset, so if I push the button 0, the LED stops.